detailed chemical kinetic model need inputs from laboratory experiments. They need kinetic and thermodata for validation before it can be used under different conditions like in CFD codes. Due to the hierarchical structure of kinetic reaction mechanisms, simple to complex chemical systems are needed to be studied. And also, some of the intermediates which are formed during the oxidation of fuels need to be studied separately in order to validate this scheme. Low temperature chemistry is much more complex than expected. And it's relatively similar to what is observed and considered in tropospheric oxidation routes. HCCI is interesting for fuel saving, but also its auto-ignition is controlled by chemical kinetics, and therefore using this engine can be interesting when we couple it with chemical kinetic analysis. And finally, biofuel combustion doesn't mean less pollutant emission. I just show an example here with ethanol, but we have more examples that show that sometimes we are producing more dangerous products when burning these oxygenates. And finally, I would like to thank the organizing and scientific committee for the invitation and for managing the system, and my colleagues who collaborated with me, some students, postdoc, or permanent employees. And I thank you very much for your attention.
Thanks very much, Professor Dagaut. We have 5 more minutes left for questions. If anyone has questions, please ask. So we'll start with the first question from Nima. Is it feasible to use the first generation of biofuels such as grapeseed directly in industrial applications?
Well, usually when we consider first generation biofuel, it's fuels coming from crops from, as I said, rapeseed, soybean in some region, sunflower. So these were competing with food. In the case of grapeseed, I don't think it is competing. As far as I know, it doesn't. So it could be considered as a second generation biofuel. So it's a very interesting biofuel, in fact.
Very good. Some audience are typing, but while they're typing, I'll ask the next question here. Any other way besides reducing, so this is a general question, any other way besides reducing combustion temperature to reduce NOx, like without using H2O? What do you think?
Yeah, well, of course, post-processing can help, like, well, as you know, in spark ignition engines, they are using 3-way catalysts, and these catalysts are able to reduce the emission of NOx. It's more difficult when you are dealing with diesel engine, because diesel engine are running fuel lean, so you have an excess of oxygen. And then one possibility is to oxidize further these nitrogen oxides to produce nitrates, which can be trapped and then separately converted to nitrogen. There are also combinations with plasma devices to do that.
Yeah, very good, thanks. So Nima, actually, this is related to the previous question about the grapeseed. He's asking, are they able to be burnt directly?
I don't think so. Well, usually when you are using seeds, you press them, you get a cake, And this cake sometimes is used for feeding animals. I'm thinking about soya, for example. And you collect oil. So you could collect oil from grape. Well, I know it, at least in France, it's available in stores. You can buy this kind of oil. It is used when you want to fry either meat or vegetable, because it's rather stable with temperature.
Very good, thanks. Another question. Best way, so this is another general question. Best way to deactivate sulfur in combustion, during combustion.
Could you repeat, please?
Best way to deactivate sulfur, like S, during combustion.
Well, sulfur, well, nowadays for transportation fuel, the level of sulfur is extremely low. It has decreased over the years, and well, it's not totally absent, but it's extremely low. Sulfur is a problem when you consider coal combustion or heavy fuels combustion, like the one which are used in marine engines, and then there are difficulties to treat them. Well, of course, in furnaces, they are using limestone, which can react with sulfur oxides and capture it. But for transportation, it's a bigger issue. That's the reason why it has been chosen to reduce the amount of sulfur in the fuel itself to avoid the formation of sulfur oxide. Several years ago, we looked at the chemistry of sulfur, and particularly we looked at the interaction between sulfur chemistry and NOx chemistry and hydrocarbon oxidation chemistry. And what we could see is that sulfur oxides are reducing the pool of radicals in the system. This is the way they interact with the chemistry. But then when you have both NOx and SOx, chemistry becomes different, and one is compensating for the other. But I don't have a
Very good, thanks.
final answer to the original question. I'm sorry for that.
Sure, no problem. I think that was good enough, probably. So, sorry, many questions came. Sorry. So, practical techniques for controlling the auto ignition control, I think. So the audience is asking which practical techniques are applied to control the auto ignition control.
The studies that we performed here were designed to try to control auto ignition in FCCI engine, which is a particular case. And so we concentrated on injection of different oxidizers. I mentioned NO, NO2, and also ozone. So this was our goal, to try to figure out which were the most powerful oxidizers that could be used. And otherwise, so in FCCI engine, in order to control classically auto ignition, they use dilution by exhaust gas, EGR. So EGR is used for that. EGR is also used to reduce flame temperature and avoid the formation of too much NOx in other conditions, like in diesel engine. I am not an engine guy, so for very practical aspects of combustion, it's a bit difficult for me to give the right answer.
I think that's a good answer. Thanks so much. So, detection of length of flame in CFT. So Amin is asking, how do we predict length of flame by OH mole fraction? Does it have a range?
I'm not able to answer this question.
Okay, next question. Thanks so much. Would you please give some comment on important species for identification of reaction zone for ethanol combustion at low temperatures?
Yes, so formaldehyde and acetaldehyde are the species that could be tracked for that. You know.
Thanks. Maddie's asked.
Go
ahead.
In the past, formaldehyde has been used to track the combustion in different devices. So this is still applying for that.
Okay, we have to cut the questions short, but I'll just ask these two questions as well. So Maddie is asking if you worked on gasoline compression ignition. He didn't ask any more detailed questions.
Well, yeah, 15 years ago, there were some interest in these GDI, but well, I have the feeling that interest is a bit gone, at least in Europe. So we don't currently work on this.
Okay, Hamid is asking, what's the impact of flameless combustion on reaction pathway of ethanol? Would it be good for reducing the emission of ethanol combustion?
Which would be good or bad? I couldn't hear well the beginning of your question.
Yeah, I'll ask again. So what's the impact of flameless combustion on reaction pathway of ethanol? Would it be good for reducing the emission of ethanol combustion?
Yes. So flameless combustion also has been a topic. Well, we've been contributed to that 20 years ago. So I don't remember all the details, but the idea is to avoid, especially a peak of temperature near the injection of the fuel, and then you are controlling the NOx formation doing that. So this was the main part, and then the emission also of unburnt species can be improved.
And we're running over time. So last question, Hadis is asking about practical techniques for controlling the NOx emission.
So for controlling NOx emission, either you need to reduce the temperature, and then you are able to reduce the importance of Zeldovich formation, the mechanism, the high temperature formation of NOx, and this is actually what they are doing in flameless combustion. You can have dilution by exhaust gas in engines, and this is used in diesel engines and in other devices. And then for, as I said before, for spark ignition engines, they are using catalysts designed to reduce NO into nitrogen. And then there are other devices that can be used, like injection of urea or ammonia, which interact with NO, and after several steps will reduce NO in N2. So it really depends on the conditions. If it's for automotives, if it's for stationary combustion, then the option will be different.
Thank you so much, Professor Dagaut, for accepting our invitation and for your presentation. We're very pleased to have you here. And for the audience, please proceed to the rooms for the rest of the conference.
Thank you very much.
Thank you so
Bye-bye.
much again. Bye. سلام خدمت حضار. بقیه کنفرانس در اتاقهای 3, 4 و 5 برگزار میشه. خواهش میکنم تشریف ببرید به اتاقهای مربوطه. خیلی ممنون. خدا نگهدار.